With Apex 2013, we've added a new Parametric Study option to the Design tab. This allows users to check system performance as a function of one or more model parameters. Let's take a look at how that works. In this example, we have an LED model comprising a bullet-shaped epoxy package, inside of which is a reflector cup and an LED chip. Let's suppose that I want to compute the far-field intensity distribution of this LED as a function of the reflector cup angle and the distance from the base of the LED to the reflector cup. I start out by going to the Design tab, clicking on Parametric to open up a new Parametric Study. In this setup view, I can add a new parameter by clicking on the Add Study parameter and selecting one of the dimensions displayed in the graphics area. Next, I specify the parameter range by setting values for the minimum and the maximum. For the reflector position, I'm going to set the minimum to 10 and the maximum to 40. Next, I specify either the step size or the total number of steps in that range. In this case, I'll specify a step size increment of 10. The program automatically computes the appropriate number of steps. Next, I'll add a new study parameter corresponding to the reflector angle. And in this case, I set the minimum to 20, the maximum to 70, and the angular step size to 10 degrees. Again, the program automatically computes the correct number of steps. If instead of specifying the step size, I specify the number of steps, the program will automatically compute the correct step size. As an option, the user can specify a constraint. However, for this example, we'll just jump over that and add a goal. In the Define Goal Property Manager, we have a choice of selecting power, intensity, irradiance, radiance, or directional power. In this case, we're looking at the far-field intensity for the LED, so I'll go with the default of intensity. Then we select a surface at which we want to compute intensity, in this case the screen. Click OK, and the goal geometry window appears. In the case of intensity, a direction cosine window is displayed. We can use the buttons at the top to select a subregion of the screen over which we want to compute intensity, but in this case I'll just go with the entire window. Then I come down here, click on the Add to Goals button, and then we close out of this view. By default, the program will report the average intensity value in addition to calculating the two-dimensional intensity distributions for each set of parameter values. To run the parametric analysis, I come up here and click on the Run button. During the run, you'll notice that the program reports the total number of trials, the current trial number, and also displays the current parameter values in the graphics pane. After the run is completed, we come over here and click on the Results view to view the total number of trials and the corresponding parameter values, the average intensity value, and the figure of merit. If I select one of the rows and then right-click in the Window column, a list of graphical options appears. First, let's look at the Variable Plot option. In this case, I've defined two variables, so I can display the window value for one or both of the variables. In this case, I'll select both of them, and then click on the Create Plot button. A three-dimensional plot appears where the horizontal axis corresponds to distance and angle, and the vertical axis corresponds to the average intensity value. However, for this parametric analysis, what we really want to see is the two-dimensional intensity values. We can show those by going back to the Parametric Results view, right-clicking on the Window column again, and then selecting Create All Picture Plots. The program automatically loads in and displays the intensity distribution for each one of the parameter set values. By clicking on the different graphical items here, I can scroll through the 2D intensity distributions corresponding to each one of the parameter configurations. So that was a quick overview of the new parametric study option in Apex 2013. This tool allows the user to develop an intuitive understanding for how system performance behaves as a function of model parameters.